Hello students, let's go for the next part of the Fourier series is Fourier series of arbitrary period 2L. Fourier series of arbitrary period 2L means in the previous video we have seen the Fourier series of the length of the period 2 pi. Now in general the length is not always the length of the interval is not always 2 pi. Okay, it may be any length of a period. We have Fourier series for any length of the period. That any length of the period is generally denoted by 2L. Means a function f of x is defined in the length of interval is other than 2 pi is 2L. A general interval of length 2L be c, c plus 2L. If f of x defined in the interval c, c plus 2 pi satisfies Dirichlet's conditions, then we have a Fourier series, that is f of x equals to a0 by 2 plus summation n equals to 1 to infinity n cos n pi x upon L plus summation n equals to 1 to infinity bn sin n pi x upon L. This is called Fourier series of arbitrary period 2L. This is called the Fourier series of arbitrary period 2L. Okay, in the previous video we have seen the Fourier series for the period 2 pi and we have solved the problems by taking the period 2 pi only. Now we are going to solve problems on the general length of the interval, that is by taking 2L, and the Fourier series for that arbitrary period 2L is given this one, f of x equals to a0 by 2 plus summation n equals to 1 to infinity an cos n pi x upon L plus summation n equals to 1 to infinity bn sin n pi x upon L. Okay. Next, Euler's formula corresponding to this series is given by a0 is equals to 1 by L integration c to c plus 2L f of x dx. An is equals to 1 by L integration c to c plus 2L f of x cos n pi x upon L into dx. Bn is equals to 1 by L integration c to c plus 2L f of x into sin n pi x upon L into dx. Okay, these are the Euler's formulae, nothing but the expressions for the constants an, coefficients an and bn. Okay, these are the expressions for this constant term a0, Fourier coefficients an and bn. These are called the four Euler's formulae. Now these are the Euler's formulae for the period 2L. Next, you can see here we have one table of contents, that is table of Fourier coefficients in the case of even and odd nature when f of x is defined in the interval minus L, L or 0, 2L. Okay, this table gives the even and odd nature. If the function is even and odd nature, then the what term we are going to get, the Fourier coefficient, this table we are going to get by the table only. Okay, nature and condition of f of x. Nature and condition of f of x means even and odd nature. Okay, if the function is even function f of minus x equals to f of x or f of 2L minus x equals to f of x. Okay, f of minus x equals to f of x when the interval is minus L to L. F of 2L minus x equals to f of x means when the interval is 0, 2L. When the function f of x defined in the interval 0, 2L, in that case by substituting x equals to 2L minus x, we are checking the nature of the function. Okay, if the interval is minus L to L, then we are checking the nature of the given function by substituting x equals to minus x. Okay, in that case, if the function is even function, then bn coefficient becomes 0. We have the a0 and bn coefficients. Then the expressions for those coefficients are nothing but 2 by L integration 0 to L f of x into dx. An is equals to 2 by L integration 0 to 1 f of x into cos n pi x upon L into dx. Okay, 2 by L means these are nothing but the expression is like this only. 1 by L integration minus L to L f of x into dx only. But by the property of integration, this we can write it as 2 by L integration 0 to L f of x into dx. Similarly, this also, this is nothing but 1 by L integration minus L to L f of x into cos n pi x upon L into dx. But by the property of integration, this we can write it as 2 by L integration 0 to L f of x into cos n pi x upon L into dx. Right? When we have the even and odd even nature, Bn coefficient becomes 0. When we have the odd nature, A0 and An becomes 0. We have the expression, we left with only coefficient Bn, and we have the expression is 2 by L integration 0 to L f of x into sin n pi x upon L into dx. Next we will go for the problems. Let's solve the problems. Obtain the Fourier series to represent f of x equals to x minus x square in minus L less than x less than L. Obtain the Fourier series to represent f of x equals to x minus x square in it's 1 minus 1 less than x less than 1. Here period of f of x equals to, now we need to find the period of a given function using the formula 2L is equals to b minus a. We need to find the length of period, that is 2L, using the formula 2L is equals to b minus a. This is, the intervals are like always a less than x less than b, like this only. We need to find 2L by the formula b minus a. Okay, that is 1 minus of minus 1, which is equals to, therefore 2L is equals to 2, L is equals to 1. Okay, next the Fourier series of f of x having period 2L is given by f of x equals to a0 by 2 plus summation n equals to 1 to infinity an cos n pi x upon L plus summation n equals to 1 to infinity bn sin n pi x upon L. Here we know that L is equals to 1, therefore we can write it as f of x equals to a0 by 2 plus summation n equals to 1 to infinity an cos n pi x plus summation n equals to 1 to infinity bn sin n pi x. Since the interval is minus 1 to 1, let us check the nature of f of x, whether it is even or odd. Okay. Let us check the nature of f of x is even or odd. F of x equals to x minus x square. Okay, since the interval is minus 1 to 1 means minus L to L, f of minus x equals to minus x minus of minus x whole square, which is nothing but minus x square, or minus into bracket x plus x square, or minus x square. Nothing but here whatever we have obtained the function when after substituting x equals to minus x, by seeing this one you can see here the given function is neither even nor odd, right? Now even means what function we need to get? Here f of x equals to x minus x square means we should get f of x equals to x minus x square, f of minus x equals to x minus x square, or f of minus x equals to minus into bracket x minus x square. We must get any of these two function. If we are f of minus x equals to, if we are getting x minus of x square, then the function is even. When if f of minus x equals to minus of x minus x square, then the function is odd. But here we have not obtained any one of this one. Therefore, which is neither equal to f of x nor equal to minus f of x. So f of x is neither even nor odd. Means f of x is neither even function nor odd function. In that case, what we have to do is we need to find all the terms, that is a naught, an and bn. Let us find a naught, an, bn by Euler's formula. If the nature is even, then we need to find only a naught and an. If the nature is odd, then we need to find only bn. Since the function is neither even nor odd, let us find all these terms. Okay. First, let us go for a naught. A naught is equals to 1 by L integration minus L to L f of x into dx, which is equals to 1 by L integration minus L to L, minus 1 to 1 x minus of x square into dx. Now integrating these terms, integration of x is x square by 2 minus integration of x square is x cube by 3 minus 1 to 1. Next, substituting the limits, upper limit 1, lower limit minus 1. A naught is equals to 1 by 2 minus 1 by 3. That is 1 by 2 minus 1 by 3. Next, minus of lower limit minus 1. That is minus 1 whole square upon 2 minus of minus 1 whole cube upon 3. Next, simplifying here, we have obtained 1 by 2 minus 1 by 3 minus 1 by 2 minus 1 by 3 plus 1 by 2 minus 1 by 2 cancels. Here we have minus 1 by 3 minus 1 by 3, which is nothing but minus 2 by 3. A naught is equals to minus 2 by 3. Next, en. En is equals to 1 by L integration minus 1 to 1 f of x into cos n pi x dx. That is 1 by 1 integration minus 1 to 1 x minus of x square into cos n pi x dx. Nothing but 1 by 1 is nothing but 1 only. That is integration of minus 1 to 1 x minus of x square into cos n pi x dx. Next, here you can see x minus x square into cos n pi x. Nothing but here we have a product applying the Bernoulli's rule for integration. En is equals to en into bracket. We know that. What is the Bernoulli's rule? That is integration of u into v dx is equals to u into integration of v dx minus u dash, that is derivative of u, double integration of v with respect to x plus u double dash triple integration of v with respect to x, so on, right? This is the Bernoulli's rule for integration. Using this rule, we can integrate this term x minus x square into sine of n pi x upon n pi minus 1 minus 2x, that is derivative of x minus x square, that 1 minus 2x. Next, 1 upon n pi as it is, integration of sine n pi x is minus cos n pi x upon n pi. Already 1 n pi is there, therefore n pi into n pi becomes n square pi square plus minus 2 into bracket. This 1 upon n square pi square keeping constant, integrating cos of n pi x, that is minus sin pi n pi x upon n into pi. Already n square pi square is there, n square pi square into n pi is n cube pi cube. Between the limits minus 1 to 1. En is equals to substituting limit sin n pi, we know that is 0, therefore second and first term becomes 0. We are left with only second term, that is n is equals to minus into bracket 1 minus cos 2x cos n pi x upon n square pi square minus 1 to 1. Next, substituting the limits and simplifying, 1 minus of 2 into 1 cos of n pi upon n square pi square minus 1 minus of 2 of minus 1 means lower limit minus 1 cos of minus n pi upon n square pi square. That is equals to, taking 1 upon n square pi square common, we have minus cos n pi minus of 3 cos n pi. Minus cos n pi minus 3 cos n pi is minus 4 cos n pi. That is 1 upon n square pi square into bracket minus cos 4 n pi Next you can see here cos n pi is minus 1 raised to n. Minus 4 is there. Minus 4 is nothing but minus 1 into 4 and minus 1 raised to n upon n square pi square. Minus 1 means minus 1 raised to 1 minus 1 raised to n. That becomes minus 1 raised to n plus 1. That is n is equals to 4 into bracket minus 1 raised to n plus 1 upon n square pi square. This is an. Next bn. Bn is equals to 1 by L integration minus 1 to 1 f of x into sin n pi x dx. 1 by 1. L is equals to 1. Integration minus 1 to 1. 1 by 1. Integration minus 1 to 1. X minus x square into sin n pi x dx. Again applying the Bernoulli's rule for this term. We have x minus x square into integration of sin n pi x is minus cos n pi x upon n pi minus into bracket 1 minus 2x into bracket minus sin n pi x upon n square pi square plus minus 2 into bracket minus cos n pi x upon n cube pi cube plus cos n pi x upon n cube pi cube between the limits minus 1 to 1. Since sin n pi is 0, this term becomes 0. We have second term, that is x minus x square into cos n pi x upon n pi minus 2 into cos n pi x upon n cube pi cube between the limits minus 1 to 1. Next substituting the limits, 1 upon minus 1 upon n pi, this one. Minus 1 upon n pi is upper limit 1, that is 1 minus 1 square into cos n pi of 1 minus into bracket minus 1 minus of minus 1 whole square into cos of minus n pi, that is minus 1. Next, for this term applying upper and lower limit, that is 2 upon n cube pi cube into bracket cos n pi of 1 minus cos of minus n pi. Right? Next simplify here. Here we have obtained, this term we have obtained 0. That is cos of minus theta is cos theta, that is cos n pi only. Cos n pi minus cos n pi 0. Therefore we have second term 0. Next here 1 minus 1 0. That means this term also we have obtained 0. We have only minus 1 by n pi into 2 into cos n pi. And the terms 0. Therefore we have bn is equals to minus 2 upon n pi into cos 2n pi. Okay. Bn is minus 2 upon n pi into bracket minus 1 raised to n. Okay. Minus 2 means minus 1 into 2. Minus 1 means minus 1 raised to 1. That becomes minus 1 raised to n plus 1. Bn is equals to 2 by n pi into bracket minus 1 raised to n plus 1. Therefore equation 1 becomes, substituting a0, an and bn values. Here we have f of x equals to minus 2 by 3 upon 2 plus summation n equals to 1 to infinity 4 into minus 1 raised to n plus 1 upon n square pi square cos n pi x plus summation n equals to 1 to infinity 2 upon n pi into bracket minus 1 raised to n plus 1 sin n pi x, or f of x equals to minus 1 by 3 plus 4 by pi square summation of n equals to 1 to infinity minus 1 raised to n plus 1 upon n square cos n pi x plus 2 upon n into summation n equals to 1 to infinity minus 1 raised to n plus 1 upon n into sin n pi x. Okay, this is the example when we have the period 2L. 2L means generally it's a general length of the interval, right? Whenever you have asked to find the Fourier series, always you need to check the nature of the given function, whether it is the length of the period is 2 pi or length of the period is 2L. First you need to check the nature. Depending on the nature you need to solve the problem. In this problem we have obtained that it is neither even nor odd. Therefore we are finding all the Fourier coefficients. Okay. After finding all the Fourier coefficients, we have obtained the Fourier series.